and welcome to the Good Health Podcast. I'm your host, Nicole Good, a registered nutritional therapy practitioner and functional medicine practitioner. Join me as we explore thyroid, brain, and fatigue conditions with positivity. From Hashimoto's to multiple sclerosis, chronic fatigue to adrenal dysfunction, I've got you covered. With expert advice and tips to help you take action now and inspiring real patient stories from successful individuals who refuse to let their health hold them back. Start your journey to good health today. And don't forget to come and join the conversation on Instagram at good_health. That's GOODE. Or visit my website at nicolegoodhealth.com to find out more. Welcome to another episode of the Good Health Podcast. I'm your host, Nicole Good, and today we're diving into the fascinating world of neuroinflammation and its connection to multiple sclerosis, commonly known as MS. So grab your favorite beverage, find a cozy spot, and let's get ready to explore the intricate relationship between our immune system, the brain, and this complex neurological condition. So in today's episode, we'll be delving into a topic that has captivated the attention of researchers, clinicians, and individuals living with MS. Understanding how inflammation impacts the delicate network of cells in our nervous system is really vital in comprehending the mechanisms behind this challenging disease. We'll explore neuroinflammation, how it plays a significant role in the development, the progression, and the symptoms of MS, and shed some light on the intricate interplay between our immune system and the brain. Throughout the episode, we're going to be uncovering some of the latest research. We're going to be discussing different types of immune cells that are involved in neuroinflammation and explore the potential triggers and drivers of this complex process. We'll also examine the impact of neuroinflammation on the integrity of the blood-brain barrier and its implications for MS. Moreover, we're going to delve into emerging therapies that aim to target neuroinflammation directly. We'll also touch upon the exciting field of neuroimmunology and how advancements in our understanding of the immune system are really paving a way for innovative therapeutic strategies. So whether you are somebody who is affected by MS, you're a healthcare professional, or you're simply just curious about this intricate relationship between the inflammation and the brain, this episode is going to provide you with valuable insights and thought-provoking discussions. So let's dive straight in. So what is neuroinflammation? So neuroinflammation refers to inflammation that occurs within the nervous system, particularly within the brain and the spinal cord, so the central nervous system. And it's characterized by the activation of immune cells and the release of pro-inflammatory molecules in response to various triggers such as infections, injury, or autoimmune processes. And neuroinflammation can be both protective and it can be detrimental in the effects on the cells of our nervous system. Very much in the same way as inflammation at the site of a wound on your skin is protective, but chronic inflammation can be detrimental. And the reason for this inflammation, the duration, and your immune response are all going to be vital in whether it's protective or whether it becomes damaging. And persistent neuroinflammation is now recognized as a really chief pathological component of almost all neurodegenerative diseases. So how does neuroinflammation impact the cells in our nervous system? While it is a natural response aimed at removing harmful substances and initiating that tissue repair, excessive or chronic neuroinflammation can lead to damage to neurons, glial cells, and the sort of surrounding structures and disrupt that normal neurological function. Microglia are the innate immune cells of the central nervous system. So they play a key role in mediating and balancing this neuroinflammatory response in our central nervous system. And they are the primary response of the immune system within the central nervous system. They also send out inflammatory signals, and these are essential in the communication between the brain and the immune system. So in an injury or in a disease, the microglia can become active. And this is an immune response to protect. However, if it becomes chronic, there has been a link found between microglia activity, neuroinflammation, and neurological or neurodegenerative diseases. So things like MS, Parkinson's, Alzheimer's, or even autism, and much more. So there are 4 different clinical severities of neuroinflammation, and the severity and the duration of neuroinflammation are important. So first, we've got transient neuroinflammation. So this is kind of the first step. It's very fast. It's kind of that short-lived inflammation that is going to act in response to something when we need it, and it's neuroprotective. So this is a good thing. Then we get a little bit further on and we get chronic neuroinflammation. So this is when the inflammation now doesn't shut off. So if it isn't downregulated and it becomes chronic, this is when it can move from being that protective inflammation to disease-inducing inflammation. And then next we get something called microglia primed neuroinflammation. And this is when the microglia take hit after hit and they become primed. So think of it like our fight or flight response. When we take stress after stress, our adrenals are turned on and they constantly, they're overworked and we get that chronic stress and anxiety. So it's much the same. When microglia become activated, they shift their functions from supportive roles into solely being an immune cell with this need to protect the brain. And then finally, stage 4, we get this neurological autoimmunity. So this is where we're going to develop disease state of some kind of neuroinflammatory illness, such as MS. So let's look at the symptoms that you might see with neuroinflammation. So the first sort of symptoms that you might see cropping up are things like brain fog, that sort of haziness, maybe a bit of difficulty recalling things, and what you might just say that sort of sluggishness of mental speed. Or maybe reduced brain endurance, so mentally may get tired more quickly. And then we kind of move into the next level of symptoms kicking in. So things like that sort of brain fatigue after you've maybe had exposure to chemicals or scents or pollutants. And this can be something really simple. So it can be things like perfume. Or you might get brain fog after certain foods. And then the next things that kind of creep in are things like fatigue, feeling sleepy, that increased need for more than your normal night's sleep, so more than 8 hours sleep. And then the next steps is sort of level 4 kind of symptoms is, we see this inability to be able to concentrate for a period of time. So our concentration might slack, our productivity might slack, and we tend to get a lack of motivation as well around this sort of stage. And then things move a little bit further and we can start to see things like inability to actually do exercise. So that can become a real difficulty. And we can get a lack of appetite. We can get some depression. And in my free guide that's available for all of you, we're going to link it in the show notes below. You can actually assess the severity of your neuroinflammation based on your symptoms. So if you want to have a go at that, you can get that in the show notes and you can have a look at assessing your symptoms and what's going on for you. So that's neuroinflammation. So let's take a look at what MS is, what multiple sclerosis is, and then we can look at the connection between the two. So MS is an autoimmune, inflammatory, neurodegenerative, demyelinating disease. So it's a neurological disease, which means it affects the brain and the spinal cord, but it's also autoimmune. It's also inflammatory. It also causes neurodegeneration. And you might heard of it described as a demyelinating disease. So that's what's happening in the brain, which we'll get to. And it's often said to be progressive. And progressive is used to describe it as a condition that will continue to get worse over your life. And while this may be true for some, it's not necessarily always the case. And I don't actually like using the word progressive in relation to MS, because you can be diagnosed with primary progressive MS or secondary progressive MS. But you can also be diagnosed with relapse remittance MS. And actually, the vast majority of people are relapse remittance. And actually, relapse remittance indicates a pattern of having flare-ups and remission as opposed to progression. So it's this kind of typical autoimmune picture that we see. And that can become progressive, but that doesn't mean that it will in everybody. And I've seen from personal experience that it doesn't always become progressive. And I've seen through clinical work that it doesn't always become progressive. So I know people who have had MS for many, many years, and they have had relapses, but, decades later, they're still stable. And this is a message that we really need to spread about MS, because the biggest thing to remember about MS is that it's a highly variable disease and it's extremely unpredictable. And it can be a very, very different journey for everyone. So we have to be careful when we are categorizing these illnesses and these diseases. So it is inflammatory, it is neurodegenerative, it is demyelinating, it is autoimmune, and it can be progressive. But if you've just had a diagnosis of MS, I don't want you to get kind of caught up on that because the journey is very different for everybody. So don't look at other people and think that that's going to be you. So MS it's actually the most common neurological disorder in young adults. And in fact, you're most likely to get diagnosed with it in your 20s or 30s. Now, that doesn't mean that you won't get diagnosed younger or older, especially older, because MS is actually notorious for taking a really long time to get diagnosed. And the actual average length of diagnosis is 7 years. But for some, it can be a lot more. So for some, it can be 15 years. For other people, I know people who have been rushed into hospital with their very first attack and, they're diagnosed within days. So it works both ways, but the average is actually 7 years. It also becomes more common in countries that are further away from the equator. So this is believed to be linked to sunlight and vitamin D. And that's why most people who are diagnosed with MS will be told to take vitamin D as a supplement. So the immune system, how it works is it protects us from bacteria and viruses that invade our body. And without the immune system, we wouldn't survive. And inflammation, as we've said, is one of those processes by which it protects us. And again, inflammation is a good thing when it's in the right place, at the site of a wound, and when it's not chronic. So for example, if a bacteria or virus gets into the body, the immune system is going to recognize it as foreign. Those white blood cells called lymphocytes, of which there's two types, the B cells and T cells, they're going to be sent to the site to try and eliminate it. That's the T cells, or to secrete antibodies and neutralize it. That's the B cells. And this leads to inflammation. So put very simply, the immune system needs to be switched on and switched off. And if it was on all the time, we would be in this constant state of inflammation, and that uses up a lot of energy. So this on switch, when it's switched on, is called the Th1 response. And the off switch is called the Th2 response. So an effectively working immune system is actually a balance between Th1 and Th2. We want it switching off and switching on and switching off again. But when we get certain conditions, sometimes you can become Th1 dominant or Th2 dominant. So this means that your immune system can either be switched on more regularly or switched off more regularly. MS is a Th1 dominant condition. So it's switched on more regularly. And this means that patients with MS will have this kind of over-exaggerated Th1 response. So the immune system is going to be on more than it ought to be. Maybe it doesn't switch off when it should. And being on more regularly means that there's going to be this increased inflammatory response. And the central nervous system, which consists of the brain and the spinal cord, in MS can become inflamed. Hence the reason why it's called an inflammatory disorder. And what happens then is the myelin sheath, which is the protective layer around the nerves, it actually gets damaged. And that is what causes the lesions that we see in people with MS. So let's look at how neuroinflammation plays a role in the development, the progression, and the symptoms of multiple sclerosis. So in the context of MS, neuroinflammation plays a crucial role in the development, the progression, and the symptoms. And it's the immune system mistakenly targeting and attacking this myelin sheath, this protective cover around the nerve fibers. And the immune-mediated attack triggers this cascade of inflammatory processes, which leads to this demyelination. So this is the damage to the myelin sheath, demyelination. And also can cause damage to the underlying nerve fibers. Now, what happens when we get demyelination and this nerve fiber damage is that the messages that are traveling along the nerves from the brain to the rest of the body, for example, they get interrupted. So they can't get where they need to go, or maybe they get there more slowly. The resulting neuroinflammation contributes then to this formation of lesions in the brain or plaques in the brain and the spinal cord. And the slowness of these messages traveling down the nerves can cause a range of neurological symptoms. And the reason it's a range is because it depends on where those lesions are on the brain or on the spinal cord. But symptoms can be things like fatigue, muscle weakness, coordination problems, vision impairments, cognitive impairments. So there's a lot of different symptoms that can come up. And the reason for this is that it is all dependent on where those lesions form. So the interplay between our brain and our immune system is very complex and it's very tightly regulated. And the brain was once actually considered to be an immune privileged organ, but it's now known to actually communicate with the immune system through various mechanisms. So we have immune cells So these are the microglia, and these are resident cells in the brain. We also have infiltrating lymphocytes, and we have peripheral immune cells that interact with neurons and other brain cells. And they influence both the physiological and the pathological processes. And dysregulation of this interplay can lead to neuroinflammation and can contribute to the development of neurological disorders like MS. And several types of these immune cells are actually involved in the neuroinflammation. So including microglia, T cells, B cells, macrophages. And the microglia, which are these resident immune cells in the central nervous system, they actually play a crucial role in initiating and regulating the immune response in the brain. The T cells and the B cells, they're the adaptive immune cells. So they infiltrate the central nervous system during a time of neuroinflammation. So that's your immune system responding. And they then contribute to this immune response and tissue damage. And then macrophages, we have both resident and also infiltrating. And they also participate in this immune response and also the phagocytosis of damaged tissue. So there's a lot of research that is going on into understanding these inflammatory processes within the brain and the spinal cord, especially within the context of disease, injury, infection, and stress. And studies have highlighted the involvement of specific inflammatory molecules, so cytokines and chemokines, in the pathogenesis of MS and the progression of neuroinflammation. Researchers are investigating genetic and environmental factors that may actually contribute to an individual's susceptibility to neuroinflammation and therefore the development of illnesses like MS. So understanding these complex mechanisms is really going to be essential for not only understanding these conditions, but also for developing targeted therapies and targeted interventions. So let's look at the blood-brain barrier on MS. So the blood-brain barrier is this protective barrier between the bloodstream and the central nervous system. And much like the gut barrier, it regulates the passage of substances into the brain. So in MS, neuroinflammation can disrupt the integrity of the blood-brain barrier. And then it allows these immune cells and molecules to infiltrate the brain and trigger further inflammation. So this is much the same as what happens in intestinal permeability. And if you want to know what intestinal permeability is, you can jump back to episode 2 of the podcast and listen to our episode on gluten and intestinal permeability. But this blood-brain barrier works in much the same way. And the breach of the blood-brain barrier contributes to this perpetuation of neuroinflammation. So it is amplifying the damage to neural tissues and it's exacerbating the symptoms of MS. So what actually triggers this neuroinflammation? So it can be triggered and mediated by lots of different factors. So we're looking at things like infections. This includes viral infections and bacterial infections. And they've been quite heavily implicated as triggers of neuroinflammation and contributing to the development and exacerbation of MS. So, for example, Epstein-Barr virus and MS. So the link between MS and EBV has been subject to such extensive research and loads of investigation. And the exact nature of the relationship is very complex. We don't fully understand it yet, but studies have now provided evidence that there is a connection between EBV and the development of MS. EBV is such a common virus that it infects actually the majority of the population worldwide. And in most cases, it just causes kind of mild symptoms. You may not even know you've had it. And it can regularly go unnoticed. But what happens in some individuals, particularly those who have a genetic predisposition? So this is where no one thing is going to trigger autoimmunity. It's where we get this kind of network of things happening. And we need to have the genetic predisposition, and then we have the environmental factors. So EBV, the infection, that can be the environmental factor, and it can be a trigger. So it can trigger an abnormal immune response and impact actually the nervous system, and then contribute to the development of autoimmune diseases such as MS. And Epstein-Barr EBV has been heavily linked now to the development of MS. And there are several really compelling findings now that support this association. So firstly, individuals with MS have been found to have a higher prevalence of past EBV infection compared to the general population. And studies have shown that the majority of individuals with MS have evidence of past exposure, and that is indicated by the presence of antibodies against the virus. We then also have studies that are examining blood samples collected before MS onset that have shown then in individuals who later go on to develop MS, they actually have higher levels of EBV antibodies compared to those who remain disease-free. And this suggests that the Epstein-Barr virus or an abnormal immune response to EBV may act as a trigger or a contributing factor in the development of MS. Researchers have also identified specific immune cells, which are called T cells, that target the EBV infected cells, and these actually cross-react with certain proteins that are found in the myelin sheath of the nerve fibers. So this cross-reactivity can actually result in an immune response that mistakenly attacks the myelin sheath. So certain proteins in the myelin sheath are similar to the EBV infected cells. This is where the immune system can get a bit mistaken, and it can lead to this characteristic demyelination that we see in MS. So it's really important to note that, while this link has now definitely been established, it's in the research, this link between EBV and MS. EBV infection alone is not sufficient to cause MS. And we know that because, like we said, the vast majority of the population will get EBV at some point, but not everybody gets MS. So there has to be other factors at play. And these are usually genetic factors and other environmental factors. And they likely play a role in the development of the disease. But EBV can definitely act as a trigger for MS. So other mediators of neuroinflammation, as well as the viral and bacterial, can include things like immune dysregulation, oxidative stress, autoimmune processes. And what we really need to do is identify and understand these triggers and mediators, because that is crucial for us to develop targeted treatments and interventions to help us to modulate this neuroinflammation that is found in diseases like MS. So that's where the research is going with this. Now, functional medicine focuses on a 360-degree systems-based holistic approach. And MS is known to be a web. So it's known to be linked to many different conditions, EBV being one of them, many different symptoms, syndromes, and also deficiencies, as well as obviously all the underlying imbalances and root causes that we want to find in an individual's body. So as well as the EBV, MS has been linked to pernicious anemia, psoriasis, Hashimoto's, low vitamin D levels, autonomic dysfunction or POTS, mitochondrial dysfunction, anxiety, adrenal dysfunction, and much more. And it's really important that we untangle this web and find out what each individual's drivers are. And it will be different for everybody with MS. So it's not the same for everyone. And that's why the functional medicine approach is really effective for these types of illnesses. And again, with this, we're seeing this link between brain, thyroid, adrenals. They're all interlinked there. And then we need to consider these underlying imbalances. So these can be just as varied. And we need to look at things like immune function, neuroinflammation, brain health, the blood-brain barrier, gut health, the gut-brain axis, because that's hugely connected, the gut and the brain, hormonal imbalances, food intolerances, nutrient imbalances, genetics, chemical sensitivities, toxic burden, mold toxicity, stress, adrenal dysfunction, movement, sleep, and so much more. And that's the approach that functional medicine takes. So we're looking at all of these things, finding out which of these are impacting each individual. And like I said, different for everybody. And then helping to balance these out to help modulate the immune system, to help balance the immune system, and to help see a benefit in symptoms and progression. So the research on holistic treatments for neuroinflammation and MS has actually shown really promising results. Lifestyle modifications such as regular exercise, stress management, sleep, supplements, diet, especially diets rich in anti-inflammatory foods, have all been found to have really positive effects in reducing neuroinflammation and therefore improving symptoms in MS patients. But the key is this full holistic plan. And the key is to find these underlying imbalances and the root causes for each individual, because we are all different and we may have the same diagnosis, but the triggers, the imbalances, all of this can be different. So I could have 5 people with MS all stood in front of me, but we might find different underlying issues going on for each one of the 5. So one might have food intolerances and chemical sensitivities. Another might have mold. Another might have adrenal dysfunction and stress. Another might have gut issues. Another might have brain health issues or hormonal imbalances. So the underlying issues can be different for everybody. So what we need to do is we need to find these underlying imbalances, we need to find these triggers, and then we need to bring the body back to balance. And that's going to really help. So as well as functional medicine, nutritional medicine, lifestyle medicine, there are also other complementary and alternative therapies that we can use. So things like acupuncture and yoga. And they're also being researched and explored for their potential in alleviating neuroinflammation. And the results are looking positive. So we really need to take this overall well-being approach to individuals with MS. Now, let's just take a quick look at a field called neuroimmunology and how these advancements are helping us to understand the immune system and how it could help to actually lead to therapeutic strategies. So from a medical point of view, neuroimmunology is an interdisciplinary field. So it focuses on the interaction between the nervous and the immune systems. And we're seeing lots of advances in this neuroimmunology that have really deepened our understanding of the immune response in the central nervous system and how it relates to these neurological disorders like MS. And these advancements are paving the way for innovative new strategies. So things that target specific immune cells or inflammatory molecules or signaling pathways that are all involved in this neuroinflammation. And if we can uncover the intricacies of neuroimmunology, researchers are hopeful that we can then develop more effective treatments that can help to modulate the immune response and mitigate neuroinflammation in MS and also other of these related conditions. So the field and the research that's going on is huge in this area, and there's a lot more that's going to come out over the coming years. So that brings us to the end of today's episode on neuroinflammation and its really intricate connection to multiple sclerosis. And I really hope that you've enjoyed today's episode on immune function, on neuroinflammation, on autoimmune disease. And don't forget that you can download my free guide on neuroinflammation and MS. So we're going to link that in the show notes. So if you want to assess your neuroinflammation or you want to read a little bit more about it, you can do that by getting that free download. And if you've enjoyed this episode, you can really help to support me by following, rating, reviewing the podcast on your chosen app. I'll see you next week. I hope you enjoyed this episode of the Good Health Podcast. Do share the episode with anyone who you think it may benefit or who may enjoy it. And help me spread the word by rating the episode or leaving a review. If you want more, you can find other episodes in the series on your podcast app or sign up to my free newsletter. Not only will you get information on new episodes launching, but we cover lots of health topics with the Ask Nicole section where you can send in your questions, my favorite recipes, my favorite products, tips and tricks to help you on the road to good health and much more. You can sign up free of charge at nicolegoodhealth.com/newsletter, also linked below. I hope you have a lovely week. Don't forget to hit subscribe and I'll see you next time.